All right. Logarithmic function. How do we apply these methods to differentiation? So recall that product rule is applied to a function y that is equal to the product of just two functions. So also, the quotient rule is applied to um, function y, which is the quotient of two functions. So what about if we have the product of um, more than two functions? Or we have the product and as well as the quotient of more than two functions. Something like this. Suppose we have y to be equals to u, v, w, the product of three functions. So how do we now differentiate this? So we use the logarithmic function idea to see the product version for three functions, product of three functions. And then we will use it as well to see the derivative for when you have the combination of both product and quotient of functions. Something like this y is equal to uv over another function w, or possibly you have something like y is equals to u over vw. Okay, so that is the idea of what of logarithmic function. So let's see how we apply it to form the product rule formula for product of three functions. Okay, so we have y to be equals to uvw. Okay, so logarithmic meaning that you're going to take log. Okay, so you take the log ln of both sides. So you have ln y equals to ln uvw. Okay, so don't forget that both the u, v, and w are all functions of what, of x. Okay, so and recall that whenever you have logarithm of products of functions, this can be written as ln u plus ln v plus ln w. That is your law of logarithm. Okay, then we will now differentiate. Remember that if you differentiate a function of x, you have to put what, the derivative after it. What I mean is differentiate ln y now, you know that will be 1 over y, right? But this is the function of x. That will now be dy dx. Are we together? Now, this will go on. We want to differentiate ln u now. That will be 1 over u. Are we together? Then we now have what? du dx plus next one 1 over v, then you have what? dv dx. Next one, plus 1 over w, and then you have what? dw dx. Okay? Now, the next thing for us to do is to multiply 2 by y, so that we only have dy dx here. Okay, so we now have that dy dx will be equal to y, Abi? Y over u du dx plus y over v dv dx plus y over w dw dx. Now let's substitute the value of y. Recall that y equals to what? uvw. So if you substitute, you're going to have that dy dx will be, if you substitute the value of y, which is uvw, you observe that what? U will cancel u, and what you will have left will now be vw. So we have vw du dx plus, you should expect that this one will become what? uw, v will have cancelled v. Okay, uw dv dx, and then w will cancel w there, and you have what left? uv dw dx. So this is the product rule version for the product of three functions. I think from this you can generate a formula for finding the derivative of product of four functions. So what do you observe? Look at this. When you are taking the derivative of u here, u will not be part of this one. It will only be vw. Just like product rule, you keep u and differentiate v, plus keep v, differentiate u. So anyone you are differentiating there, it won't be part of what we have here, what you are going to keep. So we are keeping v and w now, then we differentiate u. We are keeping u and w, then you differentiate v, and then we are keeping uv, then we differentiate w. Okay, so that's it. Okay, for y equals to uv over w, where uv and w are functions of x. So we also do what? We take the length of both sides. Okay. So applying law of logarithm here, we're going to have ln uv minus ln w. Okay. But here we still have product. So meaning that we're going to have ln u plus ln v minus ln w, okay, equals to what? Ln y. Then we now take the derivative. So the derivative of ln y is 1 over y dy dx is equals to 1 over u du dx plus 1 over v dv dx minus 1 over w dw dx. Substituting the y value, so multiplying by y, we're going to have uv over w. Okay, so we now have we have 1 over u du dx plus 1 over v dv dx minus 1 over w dw dx. So by the time we multiply 2 by y, we're going to have v over w du dx plus u over w dv dx minus uv over w squared dw dx. So that's the way to differentiate. So let's look at this example. If y equals to x squared sine x over cos 2x, find the y dx. So we have u to be equals to x squared, v to be equals to sine x, and then w to be equals to cos 2x. We need their derivative as well. So du dx to be equals to 2x, dv dx to be equals to cos x, and dw dx is equals to minus 2 sine 2x. Okay. So now recall. Remember we are having u v over w. So dy dx will be equal to u v w open bracket 1 over u du dx plus 1 over v dv dx minus 1 over w dw dx. So to substitute the value of u v w, du dx, dv dx, and dw dx, we're going to have u is x squared, v is sine x over w cos 2x, abi? Yes. So open bracket 1 over u, 1 over x squared times du dx. Du dx is 2x plus 1 over v, 1 over sine x multiplied by dv dx cos x minus 1 over w, 1 over w, which is 1 over cos 2x multiplied by minus 2 sine 2x. Okay, so simplifying this, we're going to have x squared sine x over cos 2x multiplied by 1x, we cancel x here, so you have 2 over x. Then here, this will become cos x over sine x, and cos x over x is what? Tan x. Then here, minus times minus will become plus. Then we're having 2 sine 2x over cos x, and that will be 2 tan 2x. Sine 2x over cos 2x is tan 2x. There's a problem. Here we're having cos over sine, not sine over cos. So this one is cot. This is cot x. This is cot. Yes, cot x. Cotangent of x. Cos x. So but y sine x over cos x is tan. But in this case we're having sine 2x over cos 2x, which is tan 2x. Okay. dy dx equals to, okay, keep the all products all true. So keep u and v, differentiate w. Differentiate this, what would that give us? Yeah.
Sine
Minus
4
4
sine
sine
4x
4x plus. Now keep u and w, which is x is power 5. This is x is power 5. Why am I writing x is power 2? X power 5 cos 4x. Differentiate sine 2x.
cos 2 cos 2x.
2 cos 2x plus. Now keep v and w, then differentiate u.
That's 5x4.
So with one bracket, you're going to have 5x is power 4 sine 2x cos 4x plus 2x is power 4 cos 2x cos 4x minus, because of this minus,
Yeah.
that's why I started from the last one. 4 sine
4x.
We have mixed x is power 5.
Okay.
4x is power 5 sine 2x sine 4x.